Okay, hello everyone, what's going on? This is Mohammed. Welcome to another video. In this video, I'm going to show you how to solve for this integral. So we have here the integral of dx by x plus the square root of x squared plus 1. So if you're interested, pause this video, give this problem a try, and then keep watching this video for a solution. Okay, so to solve for this integral, what I will do first, I will multiply both the numerator and the denominator by x minus the square root of x squared plus 1. Okay, so let's do that and then see what's going to happen. Okay, so we're going to multiply this by x plus, minus the square root of x squared plus 1 divided by x minus the square root of x squared plus 1. Okay, and that's gonna do what exactly? Now, as you notice, okay, the multiplication of x plus the square root, x minus the square root, it's a difference of two squares. So it's gonna give us what? The integral, okay. In the numerator, we're gonna have what? X minus the square root of x squared plus 1. And in the denominator, we're going to have the square of the first one, which is x squared, minus the square of the second one, which is basically x squared minus 1, and then dx here. And as you can notice, this is going to get canceled with this here, and we're going to be left out with -1 in the denominator, okay? So with that, let me just deactivate the mathematics here, and then that's going to leave us with the integral of the square root of x squared plus 1, that's the first integral, minus the integral of x dx. Okay, now to solve, now the second integral is pretty much straightforward now, but for the first one, okay, we're gonna do a substitution here. Okay, so we're gonna let, okay, u equals, we're gonna let x equals tangent of u. Okay, so we're gonna let x equals tangent of u, and from that, okay, or let's put it here, okay, and from that, dx is equal to secant squared of u du, okay? And let's draw a right triangle here, where the angle here is basically u, okay? So this angle here is basically u, and tangent of u is x. Okay, so x divided by 1, and that makes this, the hypotenuse of the right triangle, is equal to x squared, okay, x squared plus 1. Okay, let me just make this yellow, okay? Okay, so this right triangle is yellow, that would make it look better, okay? Okay, so now the integral I would become what exactly? Now the square root would become what? Would become 1 plus tangent squared, and that's going to be secant squared. Under the square root is going to be secant of u. Okay, so it's going to be what? Secant of u. And dx is nothing but secant squared of u du, so that's going to make it secant cube of u du. And of course, the second integral, as we said, it's pretty much straightforward, so it's going to be x squared divided by 2, and then the integration constant c. Now, for the first integral, it's pretty much a famous integral, which is basically equal to half. I'm going to show you how we got this, okay, but let me write it first. So it's going to be half secant of u tangent of u plus half again, and then the natural logarithm of the absolute value of secant of x plus tangent of u, okay? We're still working with u. So secant of u plus tangent of u, and then we close the absolute value, plus, minus x squared divided by 2 plus the integration constant c. Now, from the right triangle, we can, secant squared of u is nothing but the hypotenuse divided by the adjacent, which is the square root of x squared plus 1. And tangent is nothing but x. So this is going to be what? Half x, okay, and then the square root of x squared, x squared plus 1, and then the plus half. Now secant, as we said, okay, secant is nothing but the square root of x squared plus 1, plus the tangent of u is nothing but x, and then we close, and then minus x squared divided by 2 plus c. Okay? Now to show that how we get this, okay, let me remind you of this famous integral, which is the integral of secant square a cube of x, let's say dx. Let's solve this integral here. I will call this integral, let me call it j for the sake of simplicity, or to differentiate it, okay, from the first integral above. Okay, so I will let this be called j. Okay, so let j be equal to the integral of secant cube of x dx. Now, how can we solve this integral? Simply, we're gonna use integration by parts to solve for this integral. So what I'm gonna do here, I'm gonna let u equals secant of x. Basically here, we're gonna look at this as secant of x, secant squared of x dx. So that's how we're gonna split it. And then we're gonna let u equal to secant of x and then differentiate that. So that's gonna be what? Secant x tangent of x dx. And we're gonna let dv equals to secant squared of x dx, and that would let v equals simply tangent of x. And then we're gonna multiply this, we're gonna multiply this by this, okay, and then integrate minus the integral, let me write that in red, okay, minus the integral of this times this, okay? So let me just center this a little bit here, and then let me put it in a box just to be organized, okay? And then let me highlight this in this color here, okay? But I have to maximize this, okay? Good. Okay, so for this integral, for this second integral, which is j, so j is going to be equal to, now, secant of x, tangent of x, minus the integral of secant of x, tangent squared of x dx. Okay, now this is going to be equal to secant of x, tangent of x, the first term wouldn't change, minus. Now the second term, okay, what I'm going to do here, I'm going to replace tangent squared by secant squared minus 1. So this is going to be what? Secant squared of x minus 1 dx. And then I will distribute, okay, so this is going to be what? Equal to secant of x, tangent of x minus, and then here, this is going to be equal to the secant cube of x dx, and negative, negative, so that's going to become positive, secant of x dx. Now, as you can notice, guys, the second term here is nothing but j, which is our integral that we have started with. Okay, so I'm going to be moving this term to the other side, so we're going to have what? 2j on the right-hand side. So twice j here would be equal to what? Secant of x, tangent of x, and then plus all of us know the integral of secant, which is nothing but the natural logarithm of the natural logarithm of secant of x plus tangent of x, and then plus c, of course, which is the integration constant. All we need to do now is to just divide both sides by 2. So it's going to be half secant of x tangent of x plus half, okay, the natural logarithm of the absolute value of secant of x plus tangent of x plus c, okay? And this is exactly the result that we have used in our solution for the first integral here, okay? If you guys can, if you have noticed this, okay? So this is how we got this here, okay? If you like this video, hit like, and if this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.